Hey, how you doing? So this is Neil. I am the designer and coder and everything artist for Vampire Hunter V, which hopefully will be out in a year or two or something. So what I want to talk about here is how to design cool artificial intelligence for 2D type games. Now, the same kind of process can also be used for 3D games as well. What's really important is don't just start coding right away. I mean, you could do that, but at least have a framework in your mind how everything's going to work. You need to work out the logics of how the AI is going to work. And this is also really important even if you're not the coder. Let's say you're writing a design document. Don't just say I want the enemies to move around and shoot at the player in some intelligent way. That's, now the coder, might not design something really cool, but if you work out the logic for him, then you don't the coding part's easy after that. Like if you already know how to code, you know the language and stuff, the hard part is actually figuring out creative ways in order to create cool AI and things like that. If you can think creatively like that, you don't actually have to be a coder to bring that to life. You can actually hire a coder and then you can say, hey, this is how I want the AI to work, but it has to be worked out logically. So that's what we're going to do now. We're going to work it all out logically. So we're not going to be writing in code yet. We're going to be just working and drawing little notes to figure out how the logic's going to work. And this is important because, like I said, if you can design this part of it, the coding part is pretty easy. It's just thinking about, well, how can I make that work in code? If you already kind of have an idea of the limitations of coding and what's difficult and stuff, that even helps more. So I can actually, I know, for example, exactly how I can code these AI. And so I'm working with the limitation of what I know how to do for sure. But even if I don't know how to do it, I might still work out the logic of it and then go, okay, can I make that work? Using code, and then try to see what can I figure out to make that work. But anyway, so let's get started. I think it'd be really cool to have, this is a water level. I'm working on some water level AI. And I'm thinking, well, you can, like old school games, you can just have a creature here that just kind of shoots homing missiles or something at the player. In this case, it won't be homing missiles because it's underwater, but or maybe it shoots in this direction and like these 4 directions like this. Maybe it shoots 3 times, like a bullets this far apart, that far apart, and they continue moving, and it goes like 1, 2, 3, and then it like pauses for a second, and then it shoots again. Or maybe it shoots, 1, 2, 3 in all these 4 directions with bullets spaced like that, and it's 1, 2, 3. There's the 3 bullets, and those bullets continue to move across the screen like this until they hit something, and then they die, or go off screen, then they die to make sure your game runs good. And then maybe it turns, 45 degrees like this, and now it shoots the diagonal way. It's the same way, 1, 2, 3, 1, 2, 3. That's kind of a simple boss. You can just kind of, not boss, a simple enemy. You can just place in the level. You can also create an enemy like that and place them on a path and have it move along a path. Let's say, you design a path that's shaped like this, and then you just tell it to move from here to here and then reverse. And that's really easy to do. Like pathing in Game Maker Studio is super easy to do. It's one of the easiest ways to make AI. Now it'll move along this path at whatever speed you tell it, and it's going to be, shooting along the path. And you can just make, a couple states for this enemy, and I show you actually how to make a state machine, a finite state machine. And using my finite state machine, it's really easy to program this enemy now. So you just, you tell it, okay, I want it to shoot. That is to create an instance. So you'll have one state where it's creating an instance, this instance here. I have a really easy, I also show how to do that too, how to make a spawner and also a shooter for enemies, and you can have it have rapid fire, and you can actually control how fast it fires, or if you use it to spawn enemies instead of bullets, how fast it will spawn them. So this would be really easy. I already have all that code already done, so I can easily tell this thing to shoot 3 bullets every 3 seconds or something, right? And I can tell it how far apart the bullets are going to be. That is how fast the bullets will come out. And all that is really easy, just a couple variables, and boom, everything's changed. And now I have a whole different enemy type that shoots very differently. One that shoots slow, one that shoots fast, whatever. And I can tell it to also randomize stuff, randomize the speed to make it more difficult to figure out and things like that. So this would be a pretty easy one to figure out. So then I have to think about, well, how do I want the logic to work? So that's one description so far, but I haven't really said how like the logic, how are we going to make that work? And that's where this next part's going to come in. So I think then about the different states and what it's going to do in those states, and how am I going to switch back and forth between those states. And this is the logic part you're thinking about, you're working out. So let's say in the default state, its default state should just be sitting there, right? An idle state is usually the default state. So let's go ahead and make this first state here, I'll just, I guess, do a square, and that will be called the idle state. Like so. Let me turn it, I'm going to make my brush a little bit smaller here. Write a little more finer detail. So that would be the idle state. And then I need to switch from that state to different states. But how do I want this to work? So what I want the enemy to do is I want it to shoot, you know, however I can design that, like the shooter to work however I want it to. And I only want it to shoot when it's in a shooting state. So we need a shooting state here. So first, let's just think about the states we need. And then we'll figure out how to move between those states. Like think about how can we get it to move between those states. Each one of these states is going to have code written inside of it telling it what to do while it's in that state. So it's really, idle's really easy to, you know, don't need much code for the idle. And just basically we need to tell it what to do, what should happen when it switches to another state, which it should do probably right away. Or we can do it when it detects enemy within a certain distance. So that's, you know, that way it kind of seems intelligent, like you're swimming up to it, you don't see it doing anything, get in a certain distance, and then it starts reacting and moving, like wakes up, you know, like, oh hey, I see you. You can even have the animation, like, you know, do something like have it pop open its eyes or something, whatever kind of creature it is, and like really show that, hey, I see you, you know. That makes it seem more alive. It's all a trick, you know. AI is a trick. Just try to make it seem alive to the player. All right, so we have an idle, we have a shoot state, but remember I wanted maybe two different shoot states, so let's go with that. What if I want two different shoot states? Shoot 1 and shoot 2. So let's make, this is shoot 1. We'll make another state, and this will be shoot 2. You're probably thinking, what the hell, why is he drawing and not just coding and showing us that? Because I'm teaching how to think like a programmer, so that way, like a designer and programmer, that way, because this is the hardest part, is being able to do this part of it. The coding part's pretty simple. Like, you know, you got to be able to think about how to make AI act the way it wants, and you want it to be fun and interesting. And this is a very simple one. We'll go over another one, a little more complicated one with movement and stuff, that reactive movement, and think about different ways how to do that. But I thought this would be an easy way to kind of get into the feel of how this should work. All right, so idle, shoot, and then what other state did I say I wanted for him? I think that was it, right? He just wanted it to be able to shoot one direction, so shoot in a plus direction like this. So 4 directions. And then I wanted to be able to shoot in X direction. Just keep, those are supposed to be arrows, so I'm just kind of drawing little lines real fast. So I think that should be a simple rotate to make that happen. Rotate its angle. Just think of that if that's something I wanted to do. Boom, boom, and just go back and forth between those, and then go back to idle. That might be kind of cool. All right, so then we got to think about how we want how to move through between these. I think that's all the states I need for this one. This is a very simple enemy. So for idle, we don't need really any code except for when to do something. So when to go to one of these two states. We'll probably go to shoot 1 first. So when it's in idle, we'll have it, the code basically, what's going to tell it to switch? What's the switch condition? How about if direction to player is a certain distance? So if we're within like, you know, 200 pixels, I think that's, in my game, that should be right when the player sees it. Maybe within 100 pixels, give it time to, so we'll say when distance is 100. All right, so if distance is 100, then we're going to move to shoot 1. So if this is true, we're going to move to shoot 1. And in shoot 1, it's going to, we're going to have the code in there telling it to shoot bullets, you know, and in the crate, it's going to be up, down, left, and right. So it's going to shoot bullets, and that should be pretty easy to do. I already have the bullet spawner, or it can spawn anything, so we can make a turret out of it wherever we want. So we'll use that code to make it shoot up, down, left, and right. And all you have to do is alter it a little bit and have it create 4 different things. So right now it's just shooting, I believe, left, and I think I actually have it to where the bullets follow the last place the player was, and when the bullet was created. So that's kind of cool, but I don't want these bullets to follow the last place the player was. I can make another, you know, enemy type do that. That's more like a turret or something. In this case, I just want to just shoot up, down, left, right. That's even easier because now we just tell the bullet to create the bullet at that direction and tell it to move that direction. So in this case, you think about a 360 wheel like this. We know this is how GameMaker works. This is 0, this is 90, this is 180, and I can't remember what's down here. Well, it'd just be 90, right? 90 plus 180? And I don't even know what that is on top of my head. I should be able to do that in my head really fast, but I don't really keep up with math. So if you don't do math, you kind of like, your brain just kind of stops learning how. It's like if you were to stop speaking a certain language, like I learned Hebrew, and because I don't really ever use it anymore, I've forgotten a lot of even like simple words and stuff. Still know quite a bit of it, but anyway. So you just do. Sorry, I probably should have been doing this really quick. So let me go ahead and do that. All right, so let's go ahead and do 180 plus 90. Pretty sad that I have to do that. 270. That's what I thought. I thought it was 270, but I did 270 recently, and it didn't go straight down. I might have had something else off, maybe. I don't know. Anyway, so like that. So then we're going to say those are going to be the 4 directions it's going to shoot. So we're going to say, one is create instant, and then we'll tell the direction will be 0, another 90, and we'll have 4 different create events, and each one will create a different direction, and that's going to shoot 4 bullets simultaneously in those 4 directions. How do we then get it to shoot like that? Well, we can have another state and just figure out these. We can just figure out these things. So it's, instead of actually rotating the actual object itself, instead of rotating the object itself, how about we just choose another state with different directions? I think that's easier. Or if you think it's rotating by 45 degrees is easier, you can do that too. You can also have it rotate slowly while shooting in these 4 directions. So just have it shoot in those 4 directions only, and then have the object itself rotate, constantly rotating. And since it's constantly rotating, it's only going to shoot whenever you tell it to shoot. Then you only need really one state, the one shooting state, and then just have it shoot periodically. So that's one thing you can do. But instead, let's kind of, and actually, you know what? Now that I think about it, for this enemy, we might not even need the different shoot states and idle state. Well, I like the idle state just because you get that initial wake up. But you can also do that just within the shoot state. Just say, don't shoot until you're within. Don't run the shoot code until. Just say if distance is greater than that. If distance to player is greater than 200, whatever it is, 100, then shoot. So that way only when the player is within that distance will it actually shoot. Now the difference there is that it'll only shoot so if the player moves away from the enemy far enough, then the enemy will stop shooting. In this case, I want the enemy to keep on shooting once the player is. Actually, no. Actually, yeah, we can have it stop. So anyway. We might not even need the idle state. Now that I think about it, we might be able to just do it all within just one state. So this enemy is so simple, we might not need any states at all. But nonetheless, I'm still going to think about it and show you with states, and then we can also go, wait, but we can write that all just within one state. So we don't even need a state machine for this enemy. So that will be, so shoot 1 is going to be these 4 directions, right? So we're going to write the code and tell it to shoot in those 4 directions. So I'm just going to write a plus sign for shooting. And then we need to tell it, well, when should it move to shoot 2? What should happen? So let's say it shoots these 4 bullets. And so in this case, we don't even have to write a complicated. Yeah, let's do it this way. This way, we don't have to use my more complicated coding for. Well, it's not that complicated, actually. I teach how to do it, to make a spawner or make a shooter. It's pretty easy. It really only uses 3 different things: a variable, one alarm, and I believe 1 time ticker, so a timer, a countdown thing. So it's pretty simple. It's not very difficult to do. Or I think it uses 2 alarms and 1 variable. I can't remember. Anyway, it's on here. It's on the site, so the YouTube channel. Check it out. It's in my videos. All right. Anyway, so instead of using that or coding that, we could do something simple and just literally have 4 create instant events and create it at different directions, and then that's that. That's all you have to do. So you just tell it, shoot in these different directions. In fact, you might just use the X and Y, like where it's creating it at, and then what? No, the bullet. Let me think about this for a second. I'm trying to remember when I create the bullet. So when it creates the bullet, you're just telling it where to create it at. So instance create is going to tell it where to create it at, and then to get the bullet to actually move in different directions, We usually do that. I usually do that. I don't know if other people. I usually do that within the bullet code itself. So I'm telling the direction the bullet should go in the bullet itself. So I might have to actually create 4 different bullets, each one with their own direction. So one that has a 90 direction, 0 direction, 180, and 270 direction, and they're going to go in those 4 different directions based on. Yeah, that's one way. I think that's. I'm just trying to think if there's another way to do that. You can also tell it. Maybe set a direction. I wonder if I can just create the bullet. I'm just trying to think it out loud. I wonder if I can create the bullet inside. So when I create the instance, and then after the bullet's created, just maybe have a variable inside the bullet, and that variable will be like direction. Direction equals, and then whatever I tell it to equal. And so in this case, I can say, for when you create this, then have the bullet. I don't know. I have to think about that for a second. Let's just do it simple for right now. One way we know for sure it'll work, we'll have 4 different bullets, 4 different objects, each one with these different directions, and that's the direction the bullet will go, and the speed we tell it to go. So we then create this one. Will have 1, 2, 3, 4 lines of code here. Each one is just an instance create, and we're creating that bullet. We're creating bullet 0, bullet 90, bullet 180, bullet 270, and that's going to shoot 4 bullets in those 4 directions. That's all we need for that state. How do we exit that state? So we know how to enter the state. We enter the state for if the distance is, if the player is within 100 to this enemy, then we're going to switch to shoot. When it's in shoot though, after it shoots those 4 bullets, nothing's going to happen. It's just going to stop, and that's it. So how do we get it to keep doing stuff? We need it to do something else now. So now we can tell it either return back to idle, or we can tell it to move to shoot 2. Do we want it to shoot these 4 bullets 3 times? And then so we'll do it, we'll have, in that case, well, if we wanted to shoot it 3 times, then we're going to have to use some sort of, use my shoot code where it you can adjust how you want it to shoot. It's probably a good idea to put that in anyway, that way you can really adjust it. And because it's done with variables, you can actually adjust those variables in the create event of the object. And so you can place more than one of the same enemy type and then adjust its create variables, and that's going to make it act different. So it's going to either shoot faster than the other one, or shoot slower, or shoot more bullets, or shoot less bullets, and so forth. Anyway, so we'll have it shoot 3 bullets in these directions about that far spaced apart. And then after it shoots those bullets, we want it to do something. So in this case, we just want it to switch. We want it to switch to shoot 2 and then shoot at a different angle right away, or we want it to pause for a second before it switches to shoot 2. I'm thinking maybe it should pause for a second. So in that case, you can just have an alarm inside of shoot 1, which will have it shoot these bullets, and then it'll just wait for that alarm to tick, and then once that alarm ticks, and then it'll switch to shoot 2. That's probably an easy way to do it. So then after this code, we'll have an alarm, and we'll have the alarm be like room speed times 3 seconds is probably good. So we'll just say 3 seconds. And after that 3 seconds is up, it's going to switch to shoot 2. And then shoot 2, we'll create, and this is not the optimal way to do it. I'm just thinking of a way that would actually work. And then I know real quickly how I would make this work, and then you can optimize it to make it work differently. But you can have then 4 more bullets, each with their own direction. And I think there's a way we should be able to do this with a variable that we can adjust the direction. So direction equals this variable, or this variable equals the direction, and then we can change that variable depending, like with how when we create the bullet. So we can say create this bullet, and then make the variable equal so and so. And then each time switching that variable, each time a new bullet's created. Might be able to do something like that. Anyway, for now we'll have 4 more objects, and these objects are going to be these directions. I don't know what these numbers are. I don't want to figure it out right now. But the number, half between here, I know is 45, and then you'd figure out these 3 numbers, which is the half between these 2 numbers. Anyway, after we have those numbers, then that will be the next 4. So now we're going to create 4 more bullets, and each one, instance create, and then we'll create this bullet, this bullet, this bullet, this bullet, and yeah. So now it's shooting at an angle. So what happens now is it doesn't do anything until the player gets close to it. When the player gets close to it, it shoots these 4 bullets in the plus direction, and this will be in the X direction. And so it shoots in the plus direction, and then it waits 3 seconds, and then it moves to shoot 2, and then it shoots in the X direction. Boom, boom, boom. 3 bullets spaced apart about like this. So it shoots those 3 bullets in the X direction, and then we can have another alarm, and we can tell that alarm maybe wait 3 seconds again. And what do we want to do after that? Do we want it to return right back to the shoot one, or do we want it to go to idle? And then, we also need some sort of, probably need some sort of if statement. So, or you can just have it be active the entire time. Just have it go back and forth. If you tell this alarm to go off and go back to shoot one, now we have a loop. Now we're done. So then it's going to go back to here. It's going to run this code, go to alarm, go to here, run this code, go to here. And it's going to loop back and forth between shoot one and shoot two. And that's simple enough, and that will actually work. And then there's really no reason to, but we might want to have it deactivate, after the player gets so far away. So you can just say overall, in the enemy's step event, you can just say if the distance is greater than so and so, then stop shooting, whatever. Give some sort of variable and just say. So then when you're saying here, you're telling it to shoot, say only if this variable. So if shoot equals true, then do this. And then in the step event, you can say shoot equals false. If the player is too far away, then it'll stop shooting. So that way it's not creating bullets the entire time. It just make your game run smoother. Otherwise, it'll just keep shooting bullets on that level, even though you don't see that part of the level anymore. So you don't see the bullets shooting, but they're still shooting. And so it's still causing, it's still using processing power, and make your game can run slower if you have a bunch of those enemies there in the background. Anyway, so that's why we have the idle in the first place. So it doesn't activate. Now you could also have it just say return to idle. So you can say that's actually probably better than having to write a. Yeah, so you can just have all this be the same and just say something like in shoot one and shoot two, just have if distance is greater than, if distance to player is greater than 100, then return to idle, right? So then you just have, and then you say, state equals state's idle, and boom, there you go. Now you're back to idle. When it's in idle, it's not shooting, remember, because idle doesn't have any code. It just sits there doing nothing. We're literally like really no code at all running, and that way it doesn't really take up much power. And then you can further optimize it, all your enemy types to like either be destroyed or created depending on whether the player is in a certain distance from them. But most games that are like 2D games don't need all that kind of optimization. It's not necessary. I use like waves, and I have like certain. I have waves of enemies. So not necessarily waves. I have enemies that are not created yet. That if the player moves over a certain, like let's say the level's shaped like this, I'll have a thing here, just an invisible, to the player it's invisible, to me I can see it, but a box, and it's a collision box, and if the player collides with that box, it'll create this enemy, and this enemy. So now when the player comes over here, those enemies will be there, and you can even have it, have the enemies actually spawn around the player even, or you can have them spawn off screen. That way the player's never even aware of it. It's just optimization. All right, so anyway, there we go. That was a simple enemy type and how to think through the process. Now, obviously, we can do all this in a very different way. We don't need to use these 3 steps. We could have done all this probably without, just all in the step event. But having the different states really makes it easier to do some of this code. Like, for example, we didn't have to write all that code. We didn't have to write a variable here and say if variable shoot is true, then do this. All that's not necessary when you're using states. So it's really cool. States make things real easy. And now we're going to see how much easier it can be if we design a different kind of enemy, one that has movement, and we want it to feel a little bit more alive. Now you can really go, you can, like, for example, you can create an artificial intelligence that feels more like a living thing, like in a 3D game, like in a Call of Duty or something like that. You can make it aggressive during certain things, like if this is true and that's true, then be more aggressive. If not, go and hide. You can do all that kind of stuff, but it's really not necessary in 2D games, because you got to think about that. That's going to be a whole different kind of game. If I make an AI that works like that, that kind of AI in a water level, where it's just moving left to right in a platformer, it's going to feel, one, it's going to feel out of place, and it's not going to give me the same kind of challenge. It's going to really make the game feel different, and I think it'll make it feel slower. So instead, I want an enemy that moves around with purpose. Well, at least it might seem like it moves around with some sort of purpose, but is fun and challenging to get through certain parts. So if my level is, shaped like this, well, I guess we should make it shaped more like a square. And then, I don't know, it has like a block here and a block here. You have to like swim like this, and then there's a kind of an open area like this, and then another block like that. And you have to swim like that and get to here or something. I want to obviously I want to impede the player, and like in this part here, like to go up here like that. I want to impede the player different ways and have an enemy here doing something, to make it harder to swim through that area. And if I just have this enemy react to the player and run away from the player if the player gets too close, and if the player is getting away, then chase the player. If the player is aggressive and shooting, then run and hide behind. Maybe there's some object here and it can run and hide up here and kind of still shoot at the player or something like that. That's just not the kind of game that this is supposed to be. This is more like a Castlevania kind of game, and so that's not going to be necessary. But you don't want just like simple enemies like that only on paths and things like that. Like if you look at the enemies in Mario Brothers, the water enemies, they're really really simple. There's really no AI there. It's just like what I just created just now really wasn't an AI. It was just like a shooting thing, and that's even more complicated than Mario Brothers. Like in Mario Brothers 3, for example. I can't remember the water level right now, but I know the enemies are pretty simple. You have like jellyfish, I think, and all they do is just move straight up. They just go like this. They're just on a path, and that's all they do. They don't do anything else. Or they might kind of slightly go like this. I think there's an enemy that kind of follows the player. That's super easy. You can just do something like, like a point direction equals the player's X and Y is just going to follow the player relentlessly at a certain speed. And then you can add some sort of conditions, to tell it when to back off or not follow so quickly or whatever. Or have it do something if it gets close to the player, things like that. So that's really simple to do. And then a lot of them were just on pass. And that's kind of cool. You need something like that as well. I can just have an enemy that moves up and down on a path like this. That's the path, and it just moves up and down like this. And maybe it when it gets close to the player, it kind of goes boom, and it makes itself big like a puffer fish, and it puffs itself up for a second. And so you have to wait for it to puff itself up, and then once it starts shrinking, then you can hurry up and swim past it, something like that. Anyway, so we want something that seems to move with purpose. I want it to kind of move around within this area with purpose, but and then maybe do something like we can have it shoot 4 bullets, for example. That's still a cool thing. So we can use some of the code for that enemy we just designed. Like once we code it, and you can use some of that code for this enemy as far as the shooting goes. But we still need to have it do other things. All right. Anyway, let's think about how that's going to work. So here's my idea. My idea is obviously we need an idle state. So it's always good to start with an idle state. It's good to be able to go back to idle state when you don't want the enemy doing nothing. So we have idle state. And it won't activate unless it's within a certain distance of the player. We'll just say 200. So we'll say distance equals 200. If this is true, then we're going to switch to the new state. And I don't know what the state's going to be yet, so maybe this state will be... I should look at the house at an arrow. Oh man, that's... Hold on, let me change the size of my eraser here. Okay. Alright, so the first state I want, I think, is okay, let me think about what I'm thinking in my head, like what I want the enemy to do in my head. I'm thinking I want it to move around in some sort of random, not random way, but with purpose, but kind of random at the same time. So I want it to move around within the water only. I don't want it to go outside the water, obviously. And so that's something you have to think about, because if you just say, direction equals a random direction every so many seconds, and then let's say here's the level, right? And it starts out here. That's where you created it, and then it moves in this random direction, and now it's here. Now it can move any of these random directions because that's what you told it. And so now it moves to here in this random direction. Now it's here. And so the distance it's allowed to move is outside the water now. So now it's going to go over here. It's going to be outside the water unless you tell it. You either have some sort of collision there, which means if it hits that wall collision, it's going to keep trying to go. So you have to say, but if you collide, then stop running this code. Otherwise, it's going to keep running the code, and it's going to try to go outside the wall when it can't. So you got to think about that kind of stuff. And so I think an easy way to do that would just be basically say, if you're colliding with the water, and if it's colliding with the water, then because I have the water as an actual thing, or you can just, if you don't have the water as an actual thing to collide with, you can just create something, create a box that's just going to be an invisible box you put over where you want it to be activated, and say only if you're within this area, then do this code, and that would run here. So you would say if colliding with water. This is going to be kind of hard to write, so like small. I don't want to take up too much space. So I wonder if I can use a symbol or something. What's a good symbol for colliding? I don't know. I'll just say colliding. We'll just do something simple. So if colliding. All right, so if it's colliding with the water, you know what it means, so I told you. So these notes are just for this video only. I'm going to throw them away after that. Then I want it to move in a certain direction. So we'll say this will be move 1. So that's move 1 state. And so now it's going to go, once it's close to the player, so move to move 1 state, and move 1 state, and say if you're colliding with the water, then move. This will just mean that if it gets to the edge of the water, it'll stop moving. And then you can say something like, and if you're not colliding with the water, then move back to a certain space. And that's something we can do in a second. So here we can say, so if it's colliding with water, then do the move code. And then you can say, if not, so this is a symbol for not, if not colliding with the water, then move back to the original state you started in. So I'll just say original. So now it's going to move back to original state. Now that's easy to do actually. In the create event, you just say something like step x equals x. And because it's in the create event, step x is always, so wherever you create it. So let's say here's the room. That's this, and you create the character right here. That's the character's x position and their y position. So if in the create event of the enemy that you're creating here, you have step x equals x and step y equals y, then this is the step x and step y is always going to equal that space right there, that particular region of the room, because that's what its x and y was when it was created, right? So when the object's created, wherever you create, let's say I create over here, then here's its x and y position. That's its x and y position now, is right there. And so if on the create event you tell it, a variable equals its x and y, then that's going to be always that point right there. So wherever you create the character, that's its start x and start y now. Really easy way. It comes in handy for a lot of different things, so that's why I'm sharing it. Really cool coding tip that you can easily use to always have a character that has that original start point. And now we're going to see how that's so important for this AI. So if it moves, this is the room, if it moves up here and touches the edge and now it stops doing stuff because I told it to stop doing stuff, then I need to tell it to do something. And remember, this was well, let's say its starting point was here in the room. And it managed to get way up there, and now it's stuck against the wall. Then I would say, well, if not colliding with the water, because now it's not colliding with the water anymore, or maybe it'll never even move out of the water because it can't move if it's not colliding. But just in case, we're going to say something like that. You can also just say something like, if you reach an edge, and there's a way to like say that basically. In this case, it'd be if this is room's y. Room's y goes like this, and 0 is at the top. And let's say the room is 600 tall, then 600 would be the bottom. It's like backwards. It's intuitive. It's not intuitive. That 0 is at the top, and then left and right, 0 is over here, and let's say 600 is over here. So let's say it's a perfect square. And that would be the x. So this would be like, anyway. So you can say room height would be down here, and then this would be the room's, I guess it's y starting position. So why did I say all that? I said all that because you can use that to say, as an edge. So if the object is reached, let's say, I don't know, within room y, or its height within like 0 to, I don't know, 10, so 10 pixels or whatever. If it reaches that area, then say, if it reaches that area, then do this. Anyway, so now what we're going to do is we're going to say basically if it's not colliding, just in case it ever doesn't collide, then move back to its original position. And its original position is going to be the starting x and start y. That's what that little trick was for. So if we place enemy here in the room, that's where it's created. That's going to be its start x and start y now, and because of that little code we wrote in the create event. So now we can say, if this is true, then go back to start x and start y. So the enemy will be up here, and it'll move back here. And once it reaches there, then it's met its condition, and then now it'll do something else. But we're going to run this probably on a timer anyway to make it easy to do. All right, so right now it's in idle. It sees the enemy, or the enemy comes within a certain distance. It moves to the move 1. Once it's in move 1, it doesn't do anything yet. We haven't told any code here. We just kind of like gave some if conditions. That way we know the enemy won't go outside of the bounds, because we don't want that to happen. Now we need it to do something. We need it to move in some sort of direction. We can use the built-in direction function within GameMaker, which is really great. and built-in speeds for this. Oftentimes for AI, there's no need to make HSP and VH and all that kind of stuff. You can just use the built-in functions. They usually work good enough for enemy types. In this case, that's what we're going to do. And so I'm going to tell it to do something like move in a random direction. That might be cool. You think that will work. So then move in a random direction. Okay, so that's what we're going to do. So we're going to say move in a random direction. So that's it. So random direction, and I already know, how we can do that. We can just use the direction when you say, hey, your direction equals such and such. In this case, instead of your direction equal 90 or your direction equal whatever, just say your direction equals, and then use the random function. We can use iRandomize to make sure it's an actual integer. So iRandom, and then we'll go from like 0 to 359. Because 360 and 0 are the same thing. So 0 to 359, now it'll move anywhere randomly within within this circle radius. So it's going to move in some direction. And using iRandom is going to make it to where it doesn't move like by points. It's going to either move 1, 2, 3, 4 like that. In this case, 1, 2, 3, 4, and then 45, 46, 47, 48, 90, 91, you get the idea. And even that, it might, it's going to be random. So sometimes it might, I don't know, move like 2 in direction of 2, which can be basically like almost going this way. And then sometimes direction of 5, which is still pretty much going this way. And then maybe the next time the direction of 340, which is still, so pretty much it's always moving that direction. And so you might find that just doesn't quite work how you want it to. The randomization might not work how you want it to. So you might want to choose like specific directions that you want it to move. And maybe it's only going to move in these 8 directions only, like that. Then you just plug in those exact numbers. So instead of using random, use the function choose, and then within that you're going to choose, let's say 0, and then 45, 90. These directions here, and then whatever this number is, and then 180, and so forth. And put all those 8 numbers in there. And now it's going to randomly choose one of those directions, which I think will make it feel better. Anyway, so that's how I'm thinking I'd probably do it. So there we go. So now we have it doing something. It's moving in one direction. But it's just keep doing that indefinitely. So it's just keep moving that direction until what? Until it reaches the edge of the level. And when it reaches, and that is until it's no longer colliding, or it'll just stop and do nothing. I think that's what it'll do. I think right now, because it technically will never go outside of the water, I think it'll reach the edge and just stop and do nothing, because this will never activate. So then you can say, if speed equals 0, so you can say if not colliding, or if speed equals 0. And I'm not going to write all that, but you get the idea. So write it in your notes so you know what to say. So or if speed equals 0, then return to its original space. So then if it hits edge, it'll go back to original space. That we have something happening here. But we don't want just that. We want it to switch to another state. So we need another state to change into. And this state, so we want it to move and follow the player, and then we want it to do something and I only want it to move for a certain amount of time. So now we need to set this whole entire state, and this is all the different things it can do, and then we need to set an alarm. Alarms are awesome. They come in handy. Right? And that alarm will be, let's say, 3 seconds. 3 seconds is usually pretty good, so random speed times 3. And then so regardless of where it's at, after 3 seconds, it's going to move over here to this state. So it's going to go boom, and now we're here. Okay, so now we move from this state to this state, and then to this state. And this state maybe will be a shoot state. So maybe this is where we'll activate the shoot code. And now it's going to shoot in those 4 directions for 3 bullets. Boom, boom, boom. And maybe we can just have it based on that. After those bullets are shot, I'm trying to think what would be the best way to write it. Is there a way to kind of identify that when the 3 bullets have been shot? Well, we can just write it afterwards, so we can have it shoot the 3 bullets, and then immediately switch states. I think that might be too fast, but that's one way to do it. Remember, code is read in the order it's written. So if we write line 1, 2, 3 of code, and all those codes are shooting bullets, and then after all the shoot code, we write a code down here and say, state equals state move again. Then it'll just move back to the move state. But it's going to feel like it never stops moving. It's just going to constantly be moving, and it's going to feel like it's just going to feel like it's constantly moving. It's never going to feel like it stops for a second. It's not going to stop and shoot. Well, it will, because if in this, obviously within this state there's no movement code, so it's just going to stop, but it's going to stop for such a brief second, just long enough to shoot those 3 bullets, and then it'll start moving again. If you feel like that's not long enough, then just set another alarm in this state, how long you want it to stay in this state before it switches. So you can have it shoot the bullets, stay an alarm maybe 1 second, 2 seconds, and then go back to the move state. That's one thing. Now you have an infinite loop, and everything works great. So it'll move in a random direction. It'll stop and shoot, and then it'll move in a random direction and stop and shoot. However, I think that that's not complicated enough. That's interesting. I think that'd be an interesting enemy, and it'll occupy a certain space. If you want it to stay within a certain space, instead of if colliding with the water, you can have it if colliding with an object you create. So let's say this is the size of the room. It's a big room, let's say, and the enemy is somewhere like here, and you only want it to occupy this space like right here. And only if it's occupying that space do you want it to do this code and move around. So instead of if colliding with water, just have it say if colliding with this object. Create another object and call that object whatever you want, but something like, enemy movement. So this object here will be a circle. So you create an object that's just a circle, and you're going to make it invisible. But you'll be able to see it when you place it in the room. Reduce its opacity and its layer control, and then give it a color or whatever, and then just name it like, I don't know, enemy movement or something like that, or allow movement, something like that. So now we got this allow movement piece, and so now you say if colliding with allow movement, that is if it's within this area here, then do all this and move around. So now it's only going to move around within this area, and so if it reaches the edge or happens to go out of it, we said, well, if it's not colliding or if it reaches 0, so if it just stops moving for some reason and it reaches 0, it'll stop and start going back to its original place where we created it, which is here. And you don't have to have these match up. You can have the enemy here, right, and have that be the circle around it like that. So now it'll start moving. It'll start here, and it'll only stay within this space here. Anyway, so that's a really cool way to limit it. And yeah, so this is how it's good to think about things like this. Is what it takes to be a game designer, and or what it takes to be a programmer. I guess to be a game designer, it depends what kind of game designer you are, exactly how much they want you to think about stuff. But typically it's your job to think about all this, to think about how you want the AI to work. And this means you have to know at least a little bit of coding, understand the principles, at least understand the principles of coding, so you know the limitations. So you can't be like, all right, man, then do that. And like, we can't, that's too difficult. You have to kind of know, what's possible. Okay, so now I think everything's working good. We have a pretty cool thing here, but let's make it a lot more complicated, but without really making it more difficult, just adding a few more states. All right, so after it's done shooting, we want to have an alarm set here. So we'll have another alarm. I'm just going to write A for alarm right now. And we'll have that one set for 2 seconds. And then we'll have it switch to a different state. And this is going to be a different move state. Up here, boom. You can call these states whatever you want. This will be move 2. So now once it goes to here, it goes to here. And from here, it just goes right to move 2. It's not going to go back to any of these states for right now. Eventually, you'll see how it loops back. And in move 2, we want the code to basically be something different. Maybe move toward player for a certain amount of seconds. So now it seems like it gets aggressive for like no reason whatsoever. You can also say, how do you make it? The alarm is what sends it to here. But you can say if the alarm is sound, if alarm, and if something else, right? So if alarm is reached 0, or if the distance to player is a certain direction, and then move to move 2. If not, then move to back to move random, or move back to idle and just sit there for a second. And then from idle, if the distance is 200, so forth, then it'll start moving again. That is, if you ever send it back to idle, it's going to immediately go to move if the distance is or greater than 200. If the distance is less than 200, it's going to automatically go to move. In other words, if you send it to idle and we're close to the player, it's going to go right to move. If you send it to idle and it's not close to the player, it's just going to sit there and do nothing until the player is closest to it. So that's one thing you can do. That's good to have the idle there, so you can always send it back there as a default to do nothing, if it's not close to the player. So you can say, if this is true, and if the distance to the player is like too far away, like getting close to 200. So if distance to player is, I don't know, greater than 180, so it's almost 200. Then be aggressive. In other words, if the player is far away from you or far away from the enemy, then we want the enemy to be aggressive, that is, move toward the player. If not, we want it to just go in a random direction, or we can have it go back to its start so it never gets too far away from its original position. Remember, it's start X and start Y. So its start X and start Y, let's say, is here inside this room. And if it gets, too far over here, whatever, we want it to start making its way back here. Also, it's just a good point to use to add some what seems like territorial behavior, right? If it's always going to a state where it's trying to move back to its start position, then it seems like it's territorial, like I'm protecting this position and you shall not pass. Get out of this is my house. Get out of my house. I don't like you in my house. So I like that idea. So we're going to do that instead. We're going to make this a territorial adversary. You know what I mean? All right. So here's how we're going to do that. Move to. I'm almost wondering if it should always go, like its default should be to go back to its move thing. So we can always have, in every state, we can have an if statement that says something like, if the distance to start X and start Y. So if its X is greater than a certain amount of its start X, then we want it to go back. So obviously it's always going to be greater than it or lesser than it. So we can say something like if it's distance to X. So we can use either, I don't think we have to use length dir to do that. We probably be able to just use, I think, point. I think there's a function that's like really simple that will tell you the distance to an object. If it's distance to point. Yeah, I think that we can just use that. I think there's something like that. I think it's actually called distance to point. So we can use that function and say if distance to point. If not, I'm sure it's not that hard to write this, so this is not difficult to figure out. So if distance to point, if it's distance now, I think it chooses. I think if this code is inside the enemy, then it's saying its X and Y is going to be the original X and Y, and then the secondary X and Y is going to be, in this case, start X and start Y. And if that distance becomes whatever number we put, let's say we say 180. Then that's what's going to activate it. So I think that'll work, something like that. If not, we can figure out another way to do it. But so for now, we can say something like, so if distance to point, we'll just write it as, oops, why did I put a plus sign there? We'll just say if I'm just going to put if distance is 180. Right, so if distance is 180, what do we want to happen? If distance is 180, then we want to move back to, we want this move here. Move 2 is going to be move back to its start position. So instead of calling this move 2, we can call this go home. Or just call it home. Right, home base, it's going to go back home, back to its starting position. So if distance to 180, then well, basically just, if you guys know how to use my state machine, it's basically state equals states, dot home, whatever we call the state, and then it's going to go back home. So now it has two different ways to get to this here. After it's shooting, it's going to go to here, and after distance is here. But after shooting, it's only going to go there if what? If this is true too. So we can say if the alarm and if distance. This is hard to write all this in a small area, but I should just write 180. So now, if these two conditions are true, it goes to here. Otherwise, what should happen? We can have an else statement here. We can say else if, do what else? Or maybe there's not even, yeah, I think else if, because there's going to be probably another condition. Or maybe there's no condition, just else. Else do what? Else this. So else the state equals state's move. Else this is going to move again. So after it shoots, and actually we should say else if, because we need the alarm still. So else if, and that's going to be, and in the else if is going to be else if the alarm is 0, because we want to make sure it's waited that amount of time. So either way, whether it goes here or here, we want it to wait that full 2 seconds, the alarm to go out. So if the alarm is 0 and the distance is greater than 180, then it's going to go back. It's going to go back to home. In other words, it's like, okay, the player's far enough away from me. They're not bothering my little area, my little home, so I'm going to go back home. Otherwise, alarm is 0, and we're still close to the player. We're going to go back to random movement. If you want this to be more of an aggressive, right? So if you want this AI to be more aggressive, that is to have some sort of aggressive behavior as well, that is to chase the player down for a couple seconds before it shoots again, then you could say something like, oh, and by the way, when you have it chase the player, you might want to also put that condition in that, this condition here, stay within that radius. So remember that radius, here's the room, here's the starting point, here's the radius we gave. That was a little object. We said only if you're colliding with this object. So that way, if the player moves way over here, the enemy will only move to the edge here, and then it will stop, and then it will move back to the beginning here and protect its home. So if the enemy gets too far outside that boundary, which the enemy or the player can't see, then it's just going to reset and go back to its home. So it's only going to be aggressive to a certain area. And this actually will feel like it's intelligent, because that's how like a lot of creatures act. If you're close to their nest, they're going to be very aggressive towards you. But if you move far enough away outside of a certain radius to their nest, it'll give up and stop chasing you, because it doesn't want to get too far away from the nest. That is its babies, right? So it's only going to chase you so far, and then it's going to stop chasing you, and it's going to go back to its home base. In this case, it's going to go back to its babies or its nest. And so that actually feels realistic. So you can add that into here as well, or you can just have it be more very protective and passive. And sometimes when it moves in a random direction, that random direction will be in the way the player's going, and the player won't be able to figure out. Like sometimes it'll move away from the player, and sometimes it'll move towards the player, and the player will be like, I can't quite figure out how this thing is moving. It's good to have that random movement in there anyway, even if you are going to have another state where it chases. You don't want it to just chase the player and then return home and shoot randomly in between there, because it'll just feel too, like, I don't know, it's going to feel more like if I move this way, it's going to follow me. If I move that way, it's going to go away from me. It just doesn't feel quite right. Or if I get a certain distance away, it's going to go back anyway. So have that random movement in there. And so now, do we want also an aggressive movement? And that can be simple. So well, this right here, let's finish this one out first. This is pretty much done now, I think, actually. I think that's all we need. Oh, no, actually, we need something for home for it to tell what to do. So after it gets back home, then, or actually, well, yeah, okay, so in the home, we need code here. We need a couple lines of code that says to do something. So we're going to say something like it's x equals start x. So return home. Right, so that's when we turn it back to its original position. And that's really simple. Literally, you just say something like, if its x is greater than, or if its x doesn't equal its start x, and if its y doesn't equal its start y, then x equals start x and y equals start y, which means it's going to now return home. It's good to do that check, though, just in case it happens to be, the odds of it being right there are pretty odd, but you'll get an error if you don't have that there, because it won't know what to do. Or maybe it'll just do nothing because it's already there. But just to cover your ass, it's good to say, if it's not already there, then go there. If it's already there, obviously do nothing because you're already there. So there we go. Now we have it returning back to its home base. Okay, so now once it's at its home base, what should it do? Once it's at its home base, once it's returned, then you can say, so since we already said, if x equals start x and so forth, then return home, and it's on its way home, how do we know once it gets there? We just say else. Because else would, in this case, else would mean that it is already there, that it's reached its destination, right? Because it's going to keep going, because we told it, only if they're not equal, then go there. And so it'll go there until they're equal. Once they're equal, it's going to stop moving. Or you can just say if HSP equals 0. So that's a good way to do it. So if speed, because in this case we're using the speed and direction built-in functions. So speed equals 0, right? So if speed equals 0, do what? Return to idle. And there we go. And if the player is close enough to the enemy still at this point, then it's going to return. It's going to just go right back to its thing. If not, it's just going to stay there until the enemy gets close enough to it again. Which, if you place the enemies in the right places in your levels, then the player has to get past that section, right? So we have our level here, and let's say we have a thing like this and a thing like this, and the player has to go this way. You just have the radius be right here, bam, something like that. Or you can have the radius even be smaller, like this, and have the enemy there. So now, if the player's here and then retreats back this way, and now the enemy is back to its start position, the player still has to get past it. If the player goes up this way, and then the enemy comes back here, then the player's got past it. Now the enemy can just go like this, and everything's fine. And you know that enemy's not going to chase anymore. We can have another enemy right here. See? So now it's like, oh, okay, getting past this little section is a lot more challenging. And that's the whole point, is to make it fun and challenging for the player. Fair challenging. So there you go. So now we have a pretty cool enemy type. Now, what if we want it to be aggressive? We can take the same enemy. This is a more passive enemy. So we can use this code, and like this is a very defensive enemy. It just wants to protect its area, and it's going to like move around randomly a little bit and shoot at you, and then go right back to its home base. But what if we want something similar to this, but we want it to be aggressive as well? So if the player, in this case, if the player is, we need another state here, and this state will be chase. This is our aggressive state, and chase is basically just going to say something like, you know, like a path to player, distance to player, or follow. I can't remember the function's called right now, but it's really simple, and you just tell it to follow the player. In fact, I think I use it for my ghost. Let's check. Here's my ghost. Let's go to the script, which is the state. Ghost chase. Yeah, point direction. So I use all this right here to kind of do it, and then I have its HSP equals this and this, and I only have to do that because HSP. Because I'm not using the built-in functions for speed, then that's why I have to do it. But if not, this will actually work by itself, because you just actually I don't think it's point direction. I don't think that's the one you use. I think there's another one. Let me see here. What are the functions on here? I think this is, yeah, I think this is a tell. Make a direction. There's another one. It's like follow. Oh, move to point. That's what it's called. So there's one that's called move to point, and you'd use that. And move to point would just chase the player at a certain speed. And so the point X and Y of the move to point would be players X and players Y. Okay, so that's how you do that. And so that would chase the player. So move to point. Oops. Right, so move to point. Simple. That's the code we have there. And how long do we want it to chase the player? We don't want it to just chase the player indefinitely. Well, we could just have it chase the player while it's inside of that radius. And if the player gets outside that radius and stop chasing player, that's kind of cool. But then it's going to be like, it's going to feel like the enemy is just constantly chasing the player, because why would it, like once it moves random and then shoots, if the distance, in this case, here's probably where we're going to say if the distance to player is, right now it goes back to home. So if distance is 180, we can just say something like if players colliding with the allow movement, whatever that is, that, remember, here's the room, here's the thing, and we have that little allow movement around it. So if the player is touching this object, that is, if it's in its territory, then do something. And so that's a good way to do it. So instead of distance 180, we can just say if it's within this territory, then chase the player. The problem is, though, then it's going to just constantly be chasing the player the entire time. Now we can always put an alarm so it only chases the player for a certain amount of time and then stops and goes back to random movement or returns back home and then starts all over again. Or you can make an enemy that, my original idea actually was just to make an enemy that goes between moving randomly, shooting, chasing the player, and then home. And I can use a random function to just go between those different states. That state equals what? State equals random. Just have it constantly, each time going back to idle. We'll actually set that up right now. But anyway, so you can add this chase to movement in there instead of going back home, and it'll be a much more aggressive. So you can actually remove the home altogether if you wanted to. and it's not. But then it's going to just go between chase and random. Actually, I would always have it go back to home though. You always want that there. You want conditions at least for it to go back to home. But I would probably have it only chase the player randomly for a little bit, or for a certain amount of time. So we'll say we'll set another alarm here. That alarm will be like 2 seconds or something, maybe 3 seconds. Chase the player for 3 seconds, and then after that, switch back to shoot again. Yeah, so that way that's a good idea. So now we'll chase the player for 3 seconds. That is, it'll get closer to the player, and then it will shoot. And then after shooting, it's gonna go through its shooting, and then it's gonna wait 2 seconds. And then if the distance is 180, then it's gonna go here. If not, it's gonna go there. We can also just, instead of this being 180, we can just say if players colliding with that object, with the territorial object, the home object, whatever you want to call it, allowed movement object, whatever. I'm thinking call it home. That object is it's like this creature's home. So maybe call that home, or call that whatever you want to call it, territory. So if players colliding with home, then and alarm 2 then go here. If not, if it's outside of that radius, then just go back to move randomly. Oh no, that doesn't make any sense. Why would it do that? That's backwards, right? Let me think about that for a second. Oh, that's right. If the player's not colliding with that territory, that's what this is a similar code. So if it's not colliding with, in other words, if the player, let's go back to the room here. I should just leave this little diagram here, huh? If the player's outside of this radius, so if the player's out here somewhere, then return back to home, because now it's fine. So then return back to home. Otherwise, if the player's still somewhere in here after shooting, then let's go ahead and move around randomly. However, what makes it go to chase right now? Nothing is going to chase right now, so we need something to say go to chase. So instead of else if, we can say then go to chase. And remember, chase will automatically go back to shoot, and shoot, no, because then shoot would automatically go back to chase. We can just have it go back to idle again. That's an easy way to start the whole process over. Let's do that. So from here, so this else if statement now, because remember, now we're not saying this. Now we're saying if these now equal, this is if not connecting with home, and this is if home, right? I think. I mean, in other words, we're calling this object home. So if it's colliding with home, then see here, is that right? So if it's not colliding with home, then go to home. If it is colliding with home, so after it does all this movement, if it is colliding with home, no, if not. So yeah, these are both if nots. That's right. So if it moves randomly and then but it's not colliding with home, then it's going to go back home. So if the player's out here, it's going to go back home. And then if, what else do we have? Do we have any other way for this to move? Oh, that's right. Otherwise, it's going to shoot, right? Why did we have this here? I can't remember now. Oh, because we're putting these together, right? I think we're linking those together. We're saying if alarm 3 and if not home, then go. Oh, okay. I think I remember how to write this. If alarm 3 is this and this is, if these two are both not true, then we're going to go back and then we're going to shoot. No, that wasn't right. Hold on. We want it to shoot after all the time. So hold on a second. Let's just get rid of this. We want it shooting after it moves randomly. We want it to shoot, period. So we don't even need any of that there anymore. Something like that. So yeah. Else if return back to idle. Was that right? Because we're saying, okay, so after it shoots, it's going to return home if the alarm's gone, and if it's not home, so if the player's outside of this area, then return home. But if the player is inside this area, then what do we want it to do? Actually, maybe not idle, because that's going to start it all over again. So maybe not idle. Maybe this will go to chase. Now we have a way to get to chase. Okay, there we go. So now we have a way to get to chase. And instead of this going back to shoot, because that's just going to give us an infinite loop of, yeah, let's not go back to shoot there. Because if this goes back to shoot, if chase goes back to shoot, then it's just going to automatically go right back to chase or home only. So it's either going to go home. In other words, you're never going to go back to random movement again. So to make sure we get random movement again, we're going to go this all the way back to idle. And if the player is greater than this distance, in other words, if it's outside of this radius, then it's going to go back to move now. So now it's going to move randomly. So now it's going to just start off from moving randomly, and then it's going to shoot in those 4 directions. So it's going to shoot like this. You can also have it shoot 8 directions, however you want it to shoot. Or you can just have it shoot at the player, like a homing missile or something. And then after it shoots and the time runs out, so it's going to stop there for a second, then it's going to go back home if the player is outside. So if the player is here outside of this radius, then it's just going to go back to home. It's going to go back to the center. But if the player is inside, so if the player is still inside this radius, like here, then we're going to chase. We're going to chase down the player for 3 seconds. So we're going to chase the player, and this is where we have to put an if statement. So move to point only if we, because you don't want to, otherwise it's going to just keep chasing the player, right? Even in other words, it's going to move outside of its home. We don't want it to move outside its home, unless this is a time where you do want it to move outside its home. But once it's outside its home and it stops chasing player, oh, here we go. That's perfect. Actually, it doesn't matter if it's outside its home. We still need to make sure it can't go like outside of the water, which the player can't, so it shouldn't be able to. So let's say the player really quickly goes up here, and then that 3 seconds allows the enemy enough time to get up there before that 3 seconds runs out. And now it's outside of its territory. We haven't told it not to go outside its territory in this state. So then it's going to, after the 3 seconds is done, it's going to go back to idle. Idle only has one direction to go. From idle, there's only one thing that can happen, and that is if the distance is greater to the enemy, which in this case it's not, it's right next to it, then it's going to move. In other words, it's alive. So it's going to move. It's going to go to this move section here, and when it's in the move section or the move state, it's going to move randomly. And in this random direction, remember we have an if statement here. We say if it's colliding with this object, then we're going to move randomly. Else, if we're not colliding with this object, else if not colliding with this object, in this case you just say else, you don't have to say if. Else, which means we're not colliding with the object, then do what? Then move back to home. So it's up here, it's going to go, oh, hey, look at, I'm outside of this radius, so I can't move randomly. I have to go back home. So it's going to retreat back home. And that gives it a sense of, having some sort of intelligence. What if it takes longer than 3 seconds to move back home? In this case, 3 and 3 equal, so it should always be able to make it back home. So maybe we should say, if alarm 3 is true, there's a way to do this. So if you want to account for that to be sure it works right, you can say something like if alarm 3 is true. You see how this actually feels like you're coding, but you're not? I haven't told you how to do any code yet. This is what you have to be able to think like this first. Like this is all the thinking you have to do. Every programmer, no matter what language he's coding in, they have to think about all this. They have to work out. The logic is the same in every coding language. The logic remains the same. It's only how you get it to achieve those things that's different. And that's how the code works. So, in one coding language, how you get it to move states is different than another. You might set the state up differently. In this case, I'm just using a simple statement. If my state equals states dot idle, I'm using a simple enumerator and stuff. Hold on a second. And so there's different ways to to write those functions and stuff in different coding languages. But I don't know. I personally think that's probably the easier part to learn, unless you just have a really hard time learning that aspect of it. But I think learning the coding part isn't too difficult. It's it's just learning the proper ways to write something. The harder part is thinking about how to do everything we just did right now in this video. Is think of a logical system that is codable, a codable system to make your enemies seem intelligent. Now, if you write all this down in a document for a coder, the coder can, whatever language he's using, the coder can go, or the programmer can go, yeah, I can program that AI. That's Very well thought out. And in fact, they'll probably like super appreciate you because you just thought of a really cool way to make a really interesting AI, and they don't have to think of it because otherwise some designers might just be like, hey, I want the AI to like chase the player and be territorial, and if the player is not within the area, then don't, like they might describe it like that, and like, okay, that I don't have, like they had to now think about all this. How can I make that happen? And that's part of the fun of it. But anyway, there's one problem I do see with this, and that is in this section here. If the player, so if it happened to get outside of its box, like it did here, and then once it's outside of its box, this alarm goes off. So it only stays in this move. So it moves some random direction, like let's say it moves over here, and now it's too far away to get there. Actually, it won't move. It won't move randomly. Actually, my bad. Once it's in chase state and it chases up here, we've already said if it's outside of its area to move back to its area. So but let's say it moves and it follows the player in some direction like this, and then for some reason that is farther away. Oh yeah, I know how it can happen. So here's how it would happen. Okay, check this out. Yeah, I know my intuition felt right. This will definitely be a problem. So unless you don't mind, but let's say you have your room here, and this is now the area. That's our enemy. So it follows the player for 3 seconds, and that allows it to get, or first it moves randomly. It moves to here, and after moving randomly, it shoots, and then after it shoots, it's going to either go home or it's going to go to chase, right? It's going to go home if the player is outside here. If the player is still in here, let's say the player's here, then it's going to chase. It's going to chase for 3 seconds. The player for 3 seconds gets way over here, and he chases the player, and now the enemy is way over here. So now we have this as our enemy. That's a lot farther away because it has this extra time travel. So if it moves back, if this is 3 seconds and this is 3 seconds, it moves back to its original space only for 3 seconds. That is how long is it. So when we tell it, if we're not colliding with this object anymore, then we need to move back home, right? We need to go back home. And actually, wait, never mind. So then it's not gonna move randomly. It's gonna be here. It's not gonna move randomly because we're saying only move randomly if we're colliding with this object. So if we're not colliding with this object, then what? If we're not colliding with this object, so which is right here actually. Here it is. If not colliding with this object, we're going to go back to home. Or not back to home, we're going to go to home state. And the home state does what? It just returns us back to home. That's all it does. It does nothing else. It just no matter where the enemy's at, it returns it back to its home state, which is here, wherever we placed it, and that's where it's going to return back to. There's no alarm. The only way it moves out of this state is if speed equals 0. And the only way speed will equal 0 is if it reaches its destination. Because we're telling it to move at this speed to that point. If speed is great, well, we have to write something like, if speed is, let me think about this. If speed is greater than or equal to 0, then move to that point. No, not equal to 0, because that makes no sense. If speed is greater than 0, then move to that point. Obviously, if speed is 0, then don't move to the point. That's a simple if statement, all built in one. So that's an easy way to tell it, only move to that position if your speed is not already 0. So if once it reaches its position, then the speed will equal 0. And actually, hold on, that's not how that works. If distance, okay, hold on. If speed is greater than 0, then what? Then move to that distance. Speed won't be greater than 0 though, because we're only telling it to move. Anyway, that's another thing we have to think about coding-wise. We have to think about how to make it all move and stuff, because it's not just going to randomly. Like here, for example, we tell it move a random direction, and we also have to give it a speed. Speed equals, let's say, 4, and that's allowed to move in that random direction. And once it moves in that random direction, it now switches to shoot statement, or the shoot state. The shoot state has no speed, or actually in the shoot, if we don't say speed equals 0 in the shoot state, it's just going to keep moving at that speed in whatever direction it was already moving. It'll just never stop. Well, unless we have some other safe things to tell it to stop. Anyway, so the simple thing to do is to say speed equals 0. So once we're in the shoot state, speed equals 0. And the home the speed needs to equal something. So in this case, speed equals, we'll say speed equals 4 or whatever. That's, or maybe we can make it move faster when returning home than when just moving randomly. So here speed equals 2, here speed equals 4, something like that. So now speed equals 4 when it's in the home, unless what? Unless it's already home. So you would say if speed x, or not speed x, sorry, if x is not equal to start x, and and y is not equal to start y. In other words, if the enemy is anywhere but here, if the enemy is here, speed equals 0, else speed equals 4. And then you would say if we're not here, that is if x is not equal to start x, then do what? Then we need to tell it to move to that point. So we tell it to move that point. So now it all works. So if actually in this case, once we have that first line, then we know this. Okay, here we go. Here's how you think about it. And this is what goes through your head all the time. You're trying to think of different ways to code things, and you go, wait a minute, that's kind of a long way to do it. There's a shorter way to do that, or an easier way to think about it. And I just thought of one. So the first line of code we'll write is if speed no, we'll say speed equals 4 if something else. So we'll say if x does not equal start x, then speed equals 4. In other words, if the enemy is anywhere but here, then speed equals 4. Okay, that's one thing. We got that down. But that just means it's moving. It has a speed, but we don't know what direction is it going to move. We need to tell it to move somewhere. So let's say it's out here. This is where it's at. It needs to move back here because we're telling if that speed, if it's outside that distance. So we need to tell it. First off, we need to say if distance, or if x does not equal start x. So in other words, it's anywhere but here. Then speed equals 4. But what else do we need to know? We need to know whether it's inside this area or outside this area. Is it outside or inside its home base? Actually, never mind. We don't have to do that actually, because regardless, as long as it's not at its home base, we want it in this state. We want it to return to its home base. Okay, so we don't have to think about none of that. But let's say it happens to be here. So right now we have a way for it to have a speed, but it's not doing anything yet. It's not moving anywhere. So now we can say, so now we know if the speed is greater than 0, then what? Then it's not in its start, because we just told it that. We said if x does not equal start x, then speed equals 4. So in other words, it has a speed if it's not at home. And that's the only time we're going to give it a speed. Else speed equals 0. So now we know that speed is 0 when it is here, and if it's not there, speed is 4. But we still haven't told it to move yet. So now you can say if speed does not equal 0, then do what? Then move to point. Then move home. Move back to home. And that's as simple as using that move to point. So the move to point, the x and y is what? Start x, start y. And that's a good reason why to have that start x and start y. It makes it really easy to move back to that point. And so now we can just use one other line is all we need. If speed is not equal to 0, then move to point, start x, start y, and at speed of 4, and boom, it's going to go back to speed of 4. Actually, I was thinking about how to write this. Actually, we can probably just say if x does not equal start x, then move to point, period. Because we already know that's what we want it to move to that point. If it's not already at that point, we want it to move at that point. And then how do we get it to stop once it's at that point? So we can say if x does not equal start x, then move to point, start x, start y. So if it's out here, that's going to be true, and it's going to move to here, and we're going to move it at the speed of 4. That's all part of that. The speed movement is actually part of that function, move to point. And so it's going to move it to in that direction toward it, and then once it's, how do we tell it to stop though once it's there? Because if we don't tell it to do something, it's going to just keep moving. So then you just say, oh, it's kind of in that statement though, isn't it? Because that function is only going to work, I'm asking you like you should know, but think about it logically, it's true. Because if what's the if statement? The if statement, so in order for it to move, the if statement has to be true. If the if statement's not true, neither is the movement going to be true. However, even though the movement becomes, the function becomes untrue, I think the speed might still keep going. Yeah, I think you have to tell it to stop. I'm not sure. You have to try it and see how it works. Or I can try it and see how it works. Anyway, so if x does not, so if it's present x doesn't equal start x, which it doesn't. This is its present x is here, its start x is here, so they're not equal to each other. Then move to point start x start y. So now it's going to move back to here. Once it reaches there, that if statement is no longer true. So now it's going to keep every step, it's going to check it, and now it's going to check that statement, and its statement is going to be false because now it's actually on it. It equals it. So now x equals x. So now what you do? X equals start x. So now it no longer moved to point, but it might, because you gave it velocity, it might keep moving for some reason. So just as a, if you want to be careful to make sure that never happens, you can just say if x equals x, speed equals 0. So if x equals start x and speed equals 0. It's another quick line of code, and that will just assure that once it reaches that center point again, it'll stop moving. And there you go. Now it stops moving, and then what? And then once it's in its home state, we're just telling it once it stops moving, then, so in other words, once it's reached its home state, then it will move back to idle. And if the player is, the distance to player is greater than 200, or instead of distance to player, now you can say if the player is touching the circle, then do what? Then go back to move. And now it's in a movement. It's going to start over. It's going to move in a random direction. Let's say this time the random direction is this way, and it moves for 3 seconds. It ends up about here, and then it goes to shoot, and then it shoots its 4 directions, and then after shooting, it has an alarm goes, it pauses for 2 seconds while it's shooting, and then it's going to either go to home or it's going to go to chase. It's going to go to home if the player's outside of this, then it's going to go back home. If the player's inside of here, then it's going to chase the player, and it's going to chase the player for 3 seconds wherever the player goes, and then say it gets up here, then it's going to stop, and then because it's going to chase for 3 seconds, and then it's going to do what? Go back to idle. So now it ends up here. It goes back to idle, and then it's still inside the circle, so now it's back in the move. The move is the most complicated code so far. The code, I think the code inside of the move state will be the most complicated code. So then it's really simple though. Then if it's inside of the circle here, we're saying if you're climbing with a circle, then do a random movement. So it is still in the circle, so it does another random movement. This time it goes up this way. Goes up by here and stops here. In this case, it got outside the circle. But remember, we can keep it within the circle by telling it to only move, to say only if, say speed equals 2, whatever speed you want to move at, only if you're colliding with the circle. If you're not colliding with the circle, speed equals 0. So then it would move, and once it stops colliding with the circle right here, it would be 0 and it would stop right there. So it wouldn't actually go outside the circle in this state. It would stop right there. And then after the movement, the alarm goes off, and it's going to go to shoot again. But we're saying if it's outside of here, then we want to go to home state. Remember? Is that how we wrote that? Where is that at? No. Yeah, home right here. If we're not colliding with this circle, if we're not inside this circle, we somehow got out of it, just in case something goes wrong, we get out of the circle somehow, we want to go back to home state. And that could happen, remember, one of these states, I think it's home. Was it home state or was it chase? Oh yeah, chase state could actually get us outside of that distance, remember? Anyway, so in this case we're still inside of it, so it's going to go to shoot state. So now it goes to shoot state because we're still inside of this collision, and then we shoot, and then after shooting, it can either go home or it can go to chase. So if the player is outside of this, it'll go back home. If it's inside of this, it's going to chase him. And there you go. Now you have a really cool, there you go, look at that. See, we just designed a really cool artificial intelligence, and I did it live with you. I went through all the thinking process and everything. I think that's important because, yeah, sure, I can make another video right now after having figured all this out. I can make a video now that's much faster, like, 10, 15 minutes even. I can even do it in 5 minutes, but in such a short video, you're not, unless you're already a programmer or a coder, you're like, oh, that's a cool idea, I like that idea. All you need is a simple idea, now you know how to work with it. It's not going to teach you how to think like that. then this is kind of pointless. And it's like, hey, here's a cool idea for our AI. Here's the basic diagram or something, the basic logic behind it. And they're like, oh, that's cool. That's pretty cool. I like that. And a programmer can easily figure that out. So that a quick video would be cool for fellow programmers. But the odds are, if they can understand what I'm talking about by just quickly explaining the idea to them, like, or even just like drawing a diagram or something. In other words, if a 5-minute video makes sense to them, they don't need the video anyways. So that video is kind of pointless to make because they can already think like that. I mean, maybe it'll help them think a little bit differently. I don't know. Like, oh, I never really thought about it that way. That's pretty cool. So it might still be worth making, but it's not going to help as many people as this video will, because this video, it explains the whole process, and it takes you through my thought process. It shows what's going on in my head, how I thought all this through. And so hopefully it's been helpful to you. If it has been helpful to you, let me know in the comments. I'd appreciate it. Give it a thumbs up. If for some reason you thought this video was just utter crap, then be honest and hit the dislike button. That's your personal feeling. You truly feel that this is a worthless piece of garbage video, and that should not be on YouTube. That's what thumbs down means. When you thumbs down a video, it means that's garbage. I don't think it should even be on YouTube. So if you truly feel that way about this video, that my video is garbage and should not be on YouTube, hit the thumbs down. You're being honest. All right, cool. So, and if you just don't feel either way, just do nothing, I guess. But hopefully you'll at least give a like if you found any benefit in this video whatsoever. Even if you thought it was way too long and I jibber jabber too much, if you got any benefit out of it, hopefully you'll hit the thumbs up. So, all right, cool. Until next time, let me know what you guys want to see. If you guys have any requests, do you want to see how to code this guy? I might actually make a video now showing you how to code this. So that'd be cool. But I'm not going to do that in this video because it'll be way too long. All right, until next time.